2. Oh.
Yep. Hello, folks.
Hello.
Hello, guys. Hello.
It's a
I'll
party.
go first. I hope
Yeah.
you guys are tuning in.
Hi, everyone.
Hello. Hello, Chileong.
Hello.
Hello, Linda. Hello, Justin.
Hi everyone, Chilang Tection.
Hello.
Hello.
Yeah.
Yeah.
Okay,
Thanks for
days
joining us on a Saturday.
Okay.
Do make use. Yeah. Yeah, and so do make use of the live chat to ask your questions and let us know where you're tuning in from. We are super excited today because it's a regional event. So we have representatives from Singapore, Kuala Lumpur, and Jakarta as well. Before we begin, let me briefly introduce who we are and what we do. Google Developer Space is a platform for developers and startups around the region to learn, connect, engage, and be inspired. As part of the developer relations team, we aim to empower and connect the community to our people, programs, network, and technologies. Be it in person, like a couple of months ago, I know we all miss in-person events, but unfortunately now, or maybe fortunately, because it gave us the chance, to all be online here together today. Yeah, so for today's session, we have 3 communities from across the region. So let me just hand over to Teck Chun, who's representing Go Singapore, to share a bit more.
All right. Thank you, Justin. Hello, guys. Hello, everyone online. I'm Teck Chun from GoSG. GoSG is the local Golang community, and this is our 3rd or 4th online event. Very excited to have our co-hosts from GoKL and Go Jakarta today, and we have 3 exciting talks. Yeah, see you later. So hope you can stay online throughout. Over to you, Chileong.
Yep. I'm from the Go Kuala Lumpur. So, yep, that's about it, I guess. Yeah, just stay tuned. Just stay until the end. Yeah. And comment. Yeah. And do ask your questions. Like we have allocated time for that. So please make use of that. Yeah.
Oh yes. Okay. Winda, tell us a bit about
Yes. Hello, I'm Winda from Go Jakarta. We are running the monthly meetup for the Go programmers community in Jakarta once a month. And yeah, our founder of Go Jakarta, Kenneth, will be doing the presentation today. So be there.
very exciting. Okay, thank you guys. Without further ado, I think we can commence our talks today. First speaker, and we have 3 speakers today. First speaker is Firdaus from KL, GoKL. He's an engineering consultant at Boost. Second speaker is from Singapore, Woon. He's a student at US. And the last speaker is Kenneth. Kenneth is a familiar face in the Go circuit around the region. He's also the founder of Go Jakarta and founder of CTO and of Brankas. So let me hand over to the first speaker, Firdaus. Firdaus, maybe you can introduce yourself, and over to you for your talk.
Hello. Okay, thanks everyone for making your time on this Saturday afternoon. My name is Firdaus. So today I'm going to be talking about the temporal workflow engine. So first off, just a little bit about myself. I mostly program in Java, Kotlin, and Python. So actually Golang isn't there. I only recently started learning Golang. If you want to get in touch with me, the easiest is through LinkedIn. I'm fortunate to own this GitHub handle. I blog at this address, at this URL. I have a YouTube channel as well. I'm trying to get at least 100 subscribers so that I can get the vanity URL. So please click on this link and subscribe to my channel. Okay. If you want to email me, feel free to email me at this address. And I usually hang out at the Engineers My Slack and with this handle. Okay. Um, so the problem with talking about temporal is that temporal is a workflow engine, and everyone has their idea about what a workflow engine is. So as you can see, the space is very congested, right? There are so many projects that call themselves workflow engines. So if you've used any of these workflow engines, would you mind just mentioning in the chat Airflow or Power Automate or JPPM or JoGet, if you use any of these, so that I can get an idea of what type of workflow engines you guys are using on a regular basis. So maybe you use step functions, which is quite popular these days, or maybe you've used Power Automate. Okay. So do we have anybody commenting? Nobody so far? Okay, no issue. So, so the problem here is that when I mention the word workflow to somebody, they always have a different idea in their head, okay? So if they're from the Airflow background, then they'll think about data pipelines. If they're from the Netflix conductor background, then they'll think about microservices orchestration. So if they are from, for example, the Microsoft, the end user automation project, they might talk about Power Automate, or they might talk about Zapier, or they might talk about Salesforce Marketing Cloud. So these are all valid workflow tools, but the problem is that everyone has some different definition, and it's difficult to have some common ground for us to explain a new workflow engine, okay? So just for the purpose of this talk, if possible, just entertain me and use my definition of a workflow engine, okay? So my definition of a workflow engine is just a tool that helps you implement a long-running piece of business logic, okay? So just for this talk, you don't have to agree with it. Just let's use this definition, okay? Now, this brings us to the topic of temporal, okay? So temporal is a workflow engine, and it's written in Golang. So if, how many of you guys have heard of temporal? Okay, and how many of you guys have heard of Cadence, Uber Cadence? So Uber Cadence is a workflow engine that was started at Uber. What happens was that some of the founders of that project within Uber, they started their own company. They founded their own company, and called Temporal Technologies, and they forked the Uber Cadence source code. So this fork is actually quite important because there were some features in Uber Cadence, there were some features in Temporal that wouldn't make sense for Uber to implement, because Uber is of course focused on Uber use cases. So the most important being that Temporal uses a different RPC framework than Uber Cadence. So Uber Cadence uses Thrift with T-channel, and Temporal uses gRPC. So this change is actually very significant, but I'll talk to you about why it's significant later on, okay? And I'll talk about why the fork makes sense, okay? So with Cadence and Temporal, it's very important to explain that unlike other workflow engines, such as step functions or IFTT or Camunda, there's no DSL, there's no graphical representation. You just write the workflow in the programming language that you choose, okay? So if you want to write a workflow in Java, there's a Java SDK. If you want to write the workflow in Golang, there's a Golang SDK, right? There's no DSL, there's no graphical tool, there's no YAML, there's no directed acyclic graph like you have in Airflow, okay? You just write your normal code using loops, control structures, object-oriented, etc. Okay. Like I said, using our definition of a workflow engine, workflows in Temporal are just long-running business logic implemented as normal programming language functions. Okay. So there's nothing special about. I mean, there's not much that is special about a function in Temporal. That is that different from a function in a normal programming language, okay? So the caveat, of course, is that you need a supported language. You need a language that has a temporal SDK, right? Okay, so the easiest way to start Cadence So the easiest way, the easiest way to start Cadence is, Temporal, is to download the Docker Compose file and just run Docker Compose out. So what this will do is it will start up the Temporal service. It will start up Cassandra, which is its default database, and it will also start up Temporal Web. Okay. So so the easiest way to understand Temporal is to actually look at code. Okay. So because it is a very developer-centric tool. Okay. So unlike other tools, it's very developer-centric. So just to give you a high-level view of what components we're going to be talking about, at the center, we have the Temporal service. Okay. This is written in Golang, of course. What we're going to be developing in the next few slides is we're going to be developing the worker. Okay. So the worker contains your activities and workflows. I'm going to explain what this is about in a few minutes. But your worker will contain your activities and workflows in the programming language of your choice, right? And it interfaces with the Temporal SDK using Temporal service using the SDK, right? So the SDK is what will actually be talking to the Temporal service, okay? So later on, we'll look also at the Temporal command line tool, TCTL, and we'll look at how you can start or interface with workflows from other programs, okay? And there's also like a web GUI for you to view workflow state and workflow history and query, etc. Okay. So just a little bit more theory before we get to the code. There are two important constructs in Temporal. Okay. When you want to define a workflow in Temporal, there are two important concepts. Okay. First is the workflow function, and the second is the activity function. Okay, so the workflow function is where you would put your business logic. Okay, so the important thing to remember is that when you write your workflow function, it should only contain state transition or coordination logic. Okay, it shouldn't touch the outside world. It should not talk to a database. It should not, it should not talk to a database directly. You should not invoke a REST API directly, okay? Calls to the database or calls to a REST API or anything that can mutate the outside world or access the outside world should always be done from an activity. So the workflow should delegate to an activity to touch the outside world. But any business rules or any business logic which is independent of that can be done in the workflow function, okay? So it's very important to know the difference. Okay, your workflow functions will contain your business logic, and your activity functions will contain everything else. Okay, anything else that touches the outside world. Okay, so your database calls, your REST API calls. Okay, so let's look at one example of an activity. Okay, so this is our first activity. So remember, I mentioned just now, the activity function is where you should put all your code for accessing databases, REST APIs, etc. So here we have an activity function that hits a REST API, and it hits this get random cat fact API that I found, and it will return the cat fact. Okay, so as you can see, it kind of looks more or less like normal Golang code, right? It returns. In fact, in your activity code, you can have any Golang code. There are no restrictions. Okay, there is. I'll talk about it later, but there are restrictions about what code you can put in workflow functions. But in activity functions, you can have any logic that you like. Okay. Okay, so this is it just hits a REST API, and then it returns the value of the text field return. Okay, so there's nothing much here. This is our second activity function. So this activity function will send an email. Okay, so remember, like I stated before, if you want to invoke any external services, you need to do it through an activity function. Okay, so activity functions are just plain Golang code, right? So we've gone through two activity functions. So now let's bring them together. What we're going to do here is we're going to write a workflow that fetches a cat fact, right, and sends that cat fact to somebody through an email. Okay, So this is the actual workflow function. Okay, so this is the business logic. The business logic that we want to implement is get a random cat fact and send an email. Okay, so as you can see, it kind of looks like normal Golang code, and most Golang code, you can pretty much use any Golang construct here. There are some rules, I'll talk about it later. But you need to remember that you cannot invoke the activity directly. So if you want to invoke the activity, you need to do it through this execute activity function. Okay? So here we're invoking the activity get random cat fact, and we're getting the result, the return value in this fact variable. Okay. Then we are using that, we are passing that fact variable to the send mail activity, and then our workflow is done. Okay. So so that's basically our workflow function. Just how we saw in the earlier diagram, the workflow functions and the activity functions, they live inside a worker, right? So you need to actually create the process that will host the worker, the workflow and the activity. So this is the main process that will start, that will host it. Okay. So this is the worker process. So basically, it will connect to the temporal service here. And then it will create a client, right? And it will create a client that listens to the task queue. So I'll explain this concept in a bit, but basically what happens is that workers, they will listen on a task queue, which is a queue-like structure that's exposed by the temporal service, right? And then when it gets items in the queue, the worker will delegate it to the activity or the workflow. Okay. There's a lot more to it than that, but I'll get to that later when we talk about workflow history. Okay. So here we are registering the, here we are basically registering the workflows and the activities, and then we are running it. Okay. We are starting the worker process. Okay. Okay. So now we have the worker. So let's just catch back. Let's just look at what we've done so far. We have the temporal. We've created the activities, right? We've created the workflows, right? We've integrated them with the SDK, right? We've used the SDK. Then we have created the worker as well. Okay. So so now let's look at actually invoking the workflow. Okay. So I'm kind of running out of time. So let's do this very quickly within my window. And first off, let's start the worker process. Okay. So let's do go worker, go run worker, worker.go. Okay. What's going on here? Okay, so now the worker is running. So as you can see, the worker is running here. Okay, so okay, so you can start your workflows using two methods. One is through the SDK, right? And the other way is through the command line tool. So let's look at doing it through using the command line tool first. Okay, so let's just do this. pctl workflow run task queue cat facts and workflow type random cat email, and then execution timeout 360. Okay. So what we're doing here is we're starting the workflow using the temporal command line tool, which is which is temporal control, or sometimes I call it TCTL. And we're specifying the task queue, which is the queue that worker listens on, and we're specifying the workflow name, which is random cat email. Okay, so let's run that. Okay, so we see, so you can see that it's running, and oh, sorry, random cat fact email. Sorry, I gave the wrong name. Should be random cat fact email. Okay. Yeah. Okay. So what you're seeing here is that as the workflow is running, we are seeing that the event log or the event history of the workflow is being recorded. Okay. So what I want to highlight here is, remember that we had two activity invocations. Remember that we had two activity invocations in our workflow, right? So as you can see, there are two activity invocations here. There's an activity invocation here, and there's also an activity invocation here. Okay. We can also, now let me get back to the slides. All right, so now let me get back to the slides. So this is the output from the worker process. This is an example of us. This is an example of us invoking the workflow from another program. So it's you just use the Golang SDK, and then you can execute the workflow like this from a Golang program. So for example, if you want to, invoke it from a REST API or from a event handler or something, you can just do it like this. Okay. Okay. So I know what you're thinking, because we're looking at So I know what you're looking at. So the logic that we're implementing is very basic. So it doesn't look very interesting yet. But what's important to keep in mind is that in temporal, if you are implementing a function that takes, for example, days or weeks or months to execute, it is just like implementing any normal function. So I know there's some lag in the comments, but would any of you guys write code like this normally in Go? You wouldn't, right? You wouldn't have a sleep for 4 hours or a sleep for 30 days in normal code. And the reason you don't do that is because the process or the machine running that process, that program, might fail, right? So if that machine or process fails, then the state of that function is gone, right? Okay. So temporal, because it stores the workflow state using event sourcing, it's always able to reproduce the state of the workflow function on another machine. Okay. So that's why we can implement code like this, which sleeps for 4 days or sleeps for 30 days, and we don't have to worry about the process or the machine dying. Because if the process or machine if the process or machine that is hosting that workflow dies, we can just start up the workflow on another machine by just replaying the state of the workflow using the workflow history. Okay, so let me just go back a little bit so that you can see what's happening. So you see that in these slides, you see that there is a log of the workflow history, right? So there's actually a little bit more information in all these. Like, for example, when you invoke the activity, the parameters, the parameters and the return values are recorded in the log as well. So it's able to replay the workflow using all that information. Okay. So I'm actually running out of time, but I have way more slides, and so I'm going to rush a little bit. This workflow function, remember I mentioned just now, activity functions can contain any logic, but workflow functions have one important requirement, and this requirement is because the temporal SDK will replay the state, the history of the workflow to get the most recent state of the workflow. So in order for this replay to work, you need to follow special rules to implement your workflow. And in particular, you need to ensure that your workflow is deterministic, okay? So basically, a deterministic algorithm is just an algorithm which, according to Wikipedia, given a particular input, will always produce the same output with the underlying machine, always passing through the same sequence of states. So what this basically means is that because your workflow will be replayed multiple times, you cannot call time.now. You need to use the now that from the workflow engine, okay? Because during replay, it will give you the previous value for the current date. So same with generating random numbers and UUIDs, right? You cannot generate random numbers or UUIDs using the default Golang functions. You need to use the temporal functions because those functions will interface with the execution history, workflow execution history, so that when they replay, you'll get the same value back. Okay. Anything else? Just do it in activity functions. You can just keep it simple. Okay. I wanted to talk about signal methods and query methods, but I think we're kind of running out of time, so I'll just cover the theory. So sometimes your workflow, it needs to communicate with the outside world, right? So for example, maybe, so imagine in the example I'm going to talk about, there's going to be, we're going to talk about a loyalty program. So in this loyalty program, based on the amount that people spend, customers are assigned a tier. So the tier is either member, silver, gold, or platinum, right? So in order for the workflow to determine the tier that the customer should be given, it needs to know the transactions that they have performed, right? So what we can do, we can model this in temporal by creating a signal method. So a signal method allows outside code to update the workflow of certain state, of certain information or certain events, right? So in our example, each time the customer does a transaction, it can update the loyalty workflow of the of that customer with that transaction. Okay. So query methods are the opposite. Query methods are a way for the outside world to query the current state of the workflow. Okay. So so these are the business rules I was talking about just now. And okay, so I know this is a Golang meetup, but I think it looks far more elegant. I know this is controversial. It looks far more elegant in Java. So the Java SDK is far more elegant. So this is the interface for the workflow. So in Java, because the Java SDK uses stubs, right? So you need to use an interface and an implementation. So this is the interface of the workflow. This is the implementation. So you see, it looks very much like normal Java code. So this here is a query method, right? So you would retrieve the current tier of the customer. This here is the signal method, okay? So outside code can invoke record transaction, and it's to let the workflow know whenever the customer perform a transaction. And this is the workflow method here, okay? So with the workflow method, it sleeps. What it does is every 30 days, it will calculate the new tier of the customer based on the transactions of the previous month, okay? So you can use the temporal command line tool to invoke signals, right? As well as to query the state of workflows, okay? I wanted to show this in the terminal, but I think we're running out of time, so let's not do that. But basically what happens here is we're creating a workflow with a certain ID. And the reason we create it with a certain ID is because we want to have a well-known reference to that workflow so that we can give it signals and query it, okay? So here we are invoking a signal record transaction with the input 25, and here we're querying the transactions that the user has executed this month, as well as the customer's current tier. Okay. So I only scratched the surface. I basically wanted to show, during this talk, that with temporal, you can write functions like this. That means that you can write functions that can take as long as you need to run. So if you need them to run for a month, they can run for a month. If you need them to run for 12 months, for a year, for a decade, you can, okay? And you can do this without a DSL, without a DAG, or without YAML files. You just write normal code. So that is the main, in my opinion, that's the main value proposition of Cadence, right? So around, I'm sorry, of Temporal, okay? So around that, there are also other features that are useful in this context. There's cron workflows, child workflows. You can also have activities that take a long time to run. For example, you can have activities that start in one activity worker, but then complete in another activity worker. If you have compliance requirements, you can archive your workflow history. So workflows have a retention period, and if you pass that retention period, it's deleted. But if you want to keep it, if you want to archive it S3, it's possible. Untyped stubs are useful for, like, if you have a Java workflow that wants to communicate with a Golang activity, or vice versa. So you can use untyped stubs for that. It also supports workflow filtering. So you can assign key value attributes to your workflow, and Temporal will index this using Elasticsearch. Then you can query, you can filter your workflows based on those key value parameters using Elasticsearch. Okay. And namespaces, just like Kubernetes namespaces, more or less like Kubernetes namespaces. Okay. And there are a lot more. So this is basically the state of the project. Okay, so the temporal service is written in Golang. That's why I'm at this meetup. The database backends, the most mature one is Cassandra, because Cassandra is what they use at Uber, right? They also support MySQL, and PostgreSQL, I think, is in beta, right? So for search attribute support, you need to use Elasticsearch and Kafka, right? So it's optional. You don't need, if you don't need search, you don't need those two components. SDKs, all right. So in order to write workflows, temporal workflows, you need to use a language with a supported SDK. So currently there are only two SDKs supported by Temporal, a Golang SDK and a Java SDK. So the Java SDK, you can use Kotlin as well, or any other JVM languages. Cadence is an older project, so there are more SDKs. There is a Python SDK, which is written by me. There's a Ruby SDK, and there's a .NET SDK. So Cadence and Temporal, they're very similar behind the scenes, so it's only a matter of time before they get ported to Temporal. Okay. I didn't get a chance to show this, but there's a very cool web GUI for looking at the state of a workflow, and also for terminating and querying it. I think, because I don't have enough time to show it today, you can check it out when you launch the Docker Compose. You just go to this URL. Okay. This is the Temporal command line tool, right? And if you want to deploy Temporal in Kubernetes, there's a Helm chart. Okay. Okay, so I'll skip this slide, but I hope that I've driven home the fact that if you have this virtual function abstraction, right, this long-lived function abstraction, that you can use it for a lot of use cases. So that's basically what I wanted to drive home, that if you have this ability to write functions that, can take as long as you want to execute, what can you build on top of it? Okay, so the most popular thing is some type of microservice orchestration, gamification, loyalty, CI/CD. One of the biggest, one of the most high-profile users of Cadence is actually HashiCorp, and they use it for provisioning Consul in Azure. Okay. Okay, so I just want to talk a little bit more about. If you want some resources on the internal details, or how Cadence compares to the queue and database approach, you can look at these two presentations. Okay, there's a very good Temporal talk, Temporal forum here. So if you want to ask any questions, Temporal actually guarantees that you'll get an answer. So I usually hang out in these communities. So Python SDK in the Temporal Slack group, and Python client in the Uber Cadence group. And basically my role in the Temporal and Cadence ecosystem is that I developed the Python SDK. So the Python SDK for temporal isn't out yet, but the Cadence one is. So I'm still in the progress of porting that. And this is actually a sneak peek at how the Python SDK looks like. It's very heavily based on the Java SDK. In fact, I studied the Java SDK to figure out how to implement it in Python. Okay. And that's pretty much it. I think I've covered what I could cover in 40 minutes. Sorry about that. So can we start Q&A? Do we have time for Q&A? So what time is it? Okay, so let me have a look at some of the questions. So is there any UI dashboard to maintain the workflow? Yes. Okay, so like I said, there's no temporal is code-centric. Okay, temporal is a code-centric workflow engine. Okay, so there is no graphical tool for authoring workflows, right? But there is a dashboard for viewing the state of workflows and for terminating workflows and for querying workflows. So it's more for troubleshooting or for it's more for troubleshooting and for debugging, things like that. Okay, so that is called Temporal Web, and when you install the Docker Compose, it will be available at port 8088. Okay. How difficult is it to maintain temporal of service from an engineering perspective? Is there any? Yes. Okay. So this is a good question. Is there? So temporal. So this is the good thing about the fork. Okay, because this new company that forked Uber Cadence called Temporal Technologies, their plan is to offer a managed temporal offering, just like MongoDB Atlas, or so that we don't need to manage temporal ourselves, because I'm sure that in many companies they don't have Cassandra database DBA expertise, for example. Okay, so it's not ready yet, but a managed service will be available from Temporal Technologies sometime in the near future. Okay, because that is their main way of getting revenue. Okay. So how to handle multiple versions of the workflow when business rules changes? Okay, so this is a good question, because your workflow can take 2 months, or 2 years to run, right? So during the time, you might want to change the business logic, right? So Temporal and Cadence, they support workflow versioning. So what this means is that in the workflow code, you can query the version of the workflow, and then you can create an if to either execute the old version or the new version. Okay. So if your workflow was started in the old version, you will always get the old version ID, the old version number, and you can if based on that. Okay. What else we had? Are such long-running functions very common in businesses? Okay, yes. So the problem is because we're thinking about functions, right? So if we think about programming language functions, right? Of course, we don't think about programming language functions that take years to execute, right? Because you'll get fired if we put sleep 20 days in our code, right? But if you look at business processes, if you imagine loyalty, the loyalty program, the loyalty workflow is running as long as the customer is enrolled in that loyalty program, right? So that could be 10 years, could be 20 years, or as long as they are in that loyalty program. Okay, so the difference between Cadence and Temporal and other workflow engines which you could use to model a loyalty program is that in Temporal and Cadence, you just write a normal function. Okay, so your long-running business logic is also a long-running workflow function. Okay, so so these long-running business logic exists everywhere. Okay, so like for example, Uber for example, food delivery, any type of delivery, any type of sharing economy, subscription services, for example, etc. Okay. How much time do I have left? Around 4 minutes.
Yeah, 5 minutes or so. Yeah.
5 minutes. Okay. So what else do I have here?
I think you have
Any more questions?
You've answered most of them. In fact, all of them.
I think, let's just look at the comments.
Yeah.
Okay, so meanwhile, I just have one ask. So I was kind of expecting a question today, but I didn't get it because usually when temporal and cadence come up, people will always ask, how does this compare to airflow, right? So I prepared for this just in case I got the question, but unfortunately I didn't get the question, which is quite good because I hate when the two are compared together, okay? Because they're very, very different, right? So if I did not drive home that they're different, then that's why I included this slide. But if you guys are from an airflow background, and you would want to know more about how it compares to airflow, I'm going to do a workshop on comparing the two because the question comes out so often in the community. So I'm going to do a workshop, and if you're interested in that workshop, just click on this link and then just submit your email address. It will be sometime in December. Okay. Okay, so that's a good question, Daniel. So let me just highlight Daniel's question. Okay, so there isn't, but somebody actually implemented a step functions clone on Uber Cadence. Okay, so that's for Uber Cadence. The thing is, you can kind of think of temporal or cadence as a platform to build other workflow engines on top of, right? So for example, if you want to build a DSL, or if you want to build a BPNN engine, or you want to build a step functions clone, or you want to build a graphical workflow engine, temporal is a great base for doing that, okay? But it is not meant for non-programmers, okay? Right? You can build tools on top of that, like marketing automation tools, etc. But out of the box, there's nothing, okay? Where is it? Anything else? Yeah, I think that's pretty much it. So if you guys are interested in so if you're interested in the difference between temporal and airflow, then you can sign up for this workshop. Okay. Any more questions? My time
When is the
just
workshop?
Sure.
When is
What
the
is it?
workshop scheduled? When is the workshop scheduled?
Oh yeah, I'm doing it on the 16th of December. That's not confirmed yet, but I don't know whether there are enough people interested yet, but if there are, then I'll do it on the 16th of December. Okay.
Okay.
So I kind of rushed through some of the material because I didn't expect 30 minutes to go by that fast. Okay. So if you guys have any questions, please reach out to me, and maybe I can do a longer talk where I can. I actually wrote like 10 pages worth of notes I want to talk about, but unfortunately, when the timer started, I panicked a bit and I rushed it through. But maybe next time I can do a more in-depth talk. Okay. So thank you guys so much for having me. I'll be around for a few more minutes because I have a family event. And thank you so much, everyone.
Thank you, Firdaus. Thank you very much. I hope you enjoyed the talk. Feel free to reach out to Firdaus if you have any questions. We'll share the slides and the materials after the talk. Without further ado, let's welcome our second speaker, Woon.
Hello, am I on? Give me a second.
Yeah, go ahead.
Hello. Okay. So my screen is displayed, is it? Yes. Okay. So hello. My name is Woon, and today I'll be talking about a SQL library, a SQL query builder library for Go. Okay, so who am I? I am a computer engineering student from the National University of Singapore, and I use Go for my final year project. It was a website for facilitating like student submissions for school module, and I didn't use any ORMs. I just used vanilla SQL, and in doing so, I came across multiple pain points while developing with plain SQL in Go. Right, so these are the current problems with using the Golang's official database SQL library. So it's non-type safe. Everything is just a query string. And there is a lot of boilerplate when you're writing SQL. Handling nested structs and nulls is messy. And if you want to programmatically build queries, you have to build strings using the programming language. So what is type safety? Type safety in this context is about existence checks and data type checks. Existence checks is, let's say you have a table, it ensures that you don't try to invoke a non-existent column from the table. And data type checks is when it checks whether you're doing a valid operation on the data type. So for example, in this case, email is a string, you can't add 1 to it. And you'll notice that this is mirrored in Go, where there's also existence checks. You cannot invoke a non-existent field on a struct. And also data type checks, you can't add 1 to a string. So the SQL compiler, when it looks at SQL code, it's type safe. But the problem comes when you embed SQL code within Go code. And the Go compiler, it knows nothing about SQL code. It says, this is not type safe. So you basically lose all type information when you embed SQL within Go. And how we ensure type safety is by mapping our table schemas into native Go types so that we can reference them safely. So from something like this into something like this. Oh, okay. Yes. So if you guys have any questions during the demonstration, you can just drop it anytime in the chat, and then I'll pick up on it at the end of maybe each example. And this is a demonstration to get started with SQ. This is the table schema that we'll be using for the demonstration. To put it in words, basically there will be a bunch of teams. Each team will have multiple users, and each team will be making multiple submissions for assignments that are assigned to them. All right. So this is like many users in one team. One team can make many submissions, and each submission is targeting one assignment. Okay, right. So let me just get started with it. Okay, I have already gotten this, so I don't need to do this. I'll be using Postgres. So I'll just copy the next command. Interesting. Okay, so now I'll generate this. I'll just show you what it looks like. So you can see here when I run tables, this is like the 4 tables that I've shown you previously. Generated. Oh my god, I think it's a wrong. Wait a sec. Yeah, should be. Oh wait, that's wrong. Sorry. Copy and paste. Should be right. No, wait, what am I doing? Okay, sorry. That's the wrong URL. Okay, so you just plug in the URL that you use, SSL mode equals disable. Okay, so now you see that there's a query, and then tell you like 4 tables were written into this. And let's take a look at what this result looks like. Right, so just to bring up side by side, this is what the table looks like, and this is what the generated definitions look like. So we have, I'll show you the users table, for example, right? You've got user ID here, and it generates an equivalent struct that looks like users here. Yes, so you can see it maps like 1-to-1. There's a user ID here. It's a number field. This is a name. This is a string field. Team ID created that. It's a time field, so on and so forth. And then this is just the type definition. You've got a constructor here as well that actually gives each column their correct column names, as well as initializes the schema and the name of the table. Okay, so that's the table there. And now let's see what is next. In example 1, I'll be talking about compile time guarantees. All right, so the benefits of SQ is that it guarantees that your columns exist. It guarantees that you use the right operations on the right columns. And it guarantees that you map the data types, your columns, to the right data types. And it guarantees that you map the columns in the right order. So let's see what it looks like first without any, in the vanilla SQL way, database SQL way, right? So this is the query. There is, wait, is this, I can't really see it. Yeah, I think this is big enough. Okay, yes. So this, you can just take a look at this query. There's nothing special about it, nothing surprising. So now let's take a look at what the guarantees are. Does it fulfill the guarantees? All right. So does it guarantee that your columns exist? If I mistype this, and then I run the first example, it'll tell me that it's a compile time error. Basically, user ID doesn't exist. But the thing is, it's a runtime error. Sorry, so it's not a compile time error. So does it guarantee that I use the right operations on the right columns? Let's say I've got name not equals to email. If I do this, I can't compare a name with a number, an integer. Again, it's a runtime error, right? You can't compare text with integer over here. Okay, so does it guarantee that you map the columns to the right data type? And again, you can see here, let's see, the second one, this is a name, right? If I accidentally write user ID, that's an integer, it compiles fine, but it tells me, you know, you can't stuff a string into an int, invalid syntax, another runtime error. And does it guarantee that you map the columns in the right order? So you notice that thing about database SQL is, when you specify a order here, user ID, name, email, created at, you have to follow it exactly here, user ID, name, email, created at. If you mess up the order, let's say you mess up user email and name, you won't even get a runtime error. Everything runs fine. It's just that now you've got your name is the email and your email is the name. That's like even worse than a runtime error. It's like a logic error. And let's see now what the equivalent SQL query looks like. So we have this. This is the entire query. And this line over here just enables the logging for the query. This is the select clause, and I'll explain this in a while later, but basically select these columns from this table. This table is this initialized from this. You can see it's this constructor over here. So from this, where your conditions mentioned over here, right? These three conditions here are replicated here, and limit fetch. So does it guarantee that your columns exist? Because these are now like Go code. If you accidentally typo something, it'll throw a compiler error saying this doesn't exist. So that's good. Does it guarantee that you use the right operations on the right column? So you can see here, just now I did name not equals to user ID. Can I do it here? Nope, it's another compile time error, because if you look at the signature for this function, it actually takes in a string field and it expects a string field. And what's user ID? User ID is a number field. So it's just a very simple function mismatch. And does it guarantee that you map the columns to the right data type? So you can see here, this selection is actually, you'll notice that these are the actual columns. So how you can interpret this is, basically I want this column as an integer. I want to assign it to the user ID here, which is an integer, right? So basically I want all these columns. If I do something like this, wrong data type again, because row.int expects a number field and name is a string field. It's a string field. So you can't put the wrong data type inside these functions. And it also guarantees that you map the columns in the right order, because it doesn't actually matter what order you put these statements in. So you can mess them right up. As long as email is always mapped to email, you always get the correct mapping. You won't map email to name accidentally. I mean, you visually inspect, you see email, right? Name and name. So it guarantees that you do it in the right order. Okay, yep. So that's the benefit of using SQ. At this point, does anyone have any LT time before? Okay, so I'll just answer the questions right now. Why didn't I use an ORM or framework? Because I mean, it's not really encouraged. You know, like Go has this really do it yourself. Maybe not so, but basically you try to stick as close to. You try not to over abstract things. So basically, if your problems can be solved with SQL and my problems could be solved with SQL. Like I didn't find it too difficult to write SQL. You just stick with the simplest way. And is LT time the equivalent of before? So LT time is okay. Sorry, maybe I'll show. Okay, so basically there's a whole bunch of like comparison operators which I can show you right here. Comparison operator reference. So you've got EQ, which is equals, NE, which is not equals, GT, GE, LT, LE, right? So all these are like these. But if you additionally, you may also have a primitive type variant which only accepts the type. So basically, if you say LT time is less than time, so it has to be less than a time.time value. If you use LT by itself, it expects a time field. So that's how I get around the Golang generics, the lack of generics in Go, right? You have to specify what type you're working with, right? After. Less than time. I mean, less than time would be before, right? And after. So less than time would be before the time, and then after. GT will be after the particular time argument. Right. Okay. So yeah. So basically, this is the general syntax is you select a bunch of columns, you assign them immediately to a data type, and then after that, this function right here is basically I'll just show it side by side just to give a better example. So basically, over here you scan and you accumulate. This is the accumulation function. So for each row, you map this column to this data type, this column to this data type. And after everything is mapped, you call the accumulator function, which is just like this, right? For each row, you scan and then you accumulate. So this is you scan it in this function, you map it in this function, and you accumulate the results. And after that, you just check the errors and then it's done. Okay. Right. So moving on to the second example. Boilerplate. So the typical boilerplate, SQL boilerplate is you select the columns in a query string, right? Then you execute the query with the prepared statement parameters, fetch rows, map columns, accumulate results. Okay, it's all repetitive, unavoidable code, and you know, ORMs aren't perfect, but they make CRUD so painless though. And how SQ eliminates boilerplate is the idea of selection is mapping. So whenever you select a column, it is already mapped. The result is that all you have to do is you write the query and then you execute it and then you're done. So you can see in the example right here, actually, previously over here, right? So you see here, when you select a column, you can immediately map it into a variable and then you just write the query, right? You just write the query, you check for errors, and then you're done. After this line, you print the users and it comes out. Whereas in the normal way, you have to prepare the query, execute with params, scan, accumulate, check error like here, here, and here, and then after that, you're done. So this is all, the boilerplate is gone. But what's better is that this mapping function here, right? This thing you see right here is a function, and functions are reusable. So let's talk about it in terms of this scenario. What happens if you add a new column to a table, let's say during a migration, and you also have to upgrade the corresponding struct field, right? So in vanilla, you have to update every single SQL query that you run with the extra column, whereas in SQ, just update the mapper function. And I'll show you the example here in X2. Okay, so in this example, we actually have three queries, right? So basically, they're all the same except for the condition that you're selecting from. So you basically select a bunch of stuff from users where get all users whose name start with A. Scenario 2 is get all users whose user ID are the first 10 even numbers. And the scenario 3 is get all users whose name, email, tuple are in this particular list, right? So it has to be this and this, or this and this, or this and this. Okay, so this is 3 queries, and all of them select exactly the same thing. User ID, name, email, created at, right? User ID, name, email, created at. And now I'll add a new column. So I have prepared one right here. Let's say I'm going to add a profile picture to the users table. And now I will also have to update my database. So I think file goes to SQL run. And I have to regenerate the definitions. So for tables, if you check if you check tables.go, you notice that the profile picture field has now been regenerated by this function right here. And so now I will also have to update the user struct definition. So down here, I'll add profile picture, which is a string. It's a link. It's a string. All right. Okay. So now before I run it, I'll just run the second example without any changes to the code first. You see that I have profile picture as an empty string because I haven't done anything to handle it yet. And now I will have to user ID, right? I have to add this column to every single query that requires a list of users because you want every single aspect of the user, right? And not just that, you also have to update the scan list. So now I have to also update and user.profile picture and second query as well, and the third query as well. All right, now let's run it again. And now you can see the, oh, that's kind of, did I do something? Oh my God, I wrote user ID. Give me a sec. Give me a sec. Profile picture. All right. All right. Okay. Now I get profile picture. I get a link. Okay. So yeah. So this is it. And now let's look at what the SQ does. All right. So if you take a look at this, it's the exact same 3 scenarios, except this time you'll notice that what used to be, let's say, let's take a look at X1 SQ. Okay, so what used to be this function here is, remember, it's a function, a mapper function followed by a accumulator function. Down here, this is the mapper function. It's a name function right now. And now you've got an accumulator function. Let's take a look at what the mapper function is like. It's exactly the same code here. So basically, you just refactor it out into its own function. And now, because I have this in its own function, I can use it in every single query. So every single query, I'm invoking this particular function here and this particular function here as well. So what happens if I want to update oops. Yep. So this is the function. What happens if I want to add a profile picture? I just have to do user profile picture equals to row.string and then this is the argument here, right? I'm passing a reference to a table so that I can call the columns on it. Profile picture. All right. So now I'm mapping the profile picture column to this struct, just one line. And then if I run this, the SQ version, you'll notice that it updates as well, right? So this, and I'll just show you the log as well. So basically, all of these queries I've been enabling the log. Yep, I've been enabling the log, so with default log, just so that you can see what the log looks like. It looks like this, basically. Executing query, it'll show you the raw query with the placeholder arguments, followed by the arguments. With bind values, it will now interpolate those arguments in, so you can actually copy this query. You can copy this query and run it inside your, oh shit. You can run it inside. So I'll have to change it a little. Yeah, so you can run it inside and it'll give you the exact same data that your application will be getting. And then it'll show the first 5 results. So basically, that's what the log does. And yeah, so by enabling that one line, you will see that profile picture is now in every single query. Every single query that I run has this profile picture column inside as well. And if I take that away, so if I go to example 2 and I comment this out, I run the query again, is that now it's all empty. So just this one line can control the selection columns for 3 different queries because they all use the same mapper function. Okay. Yes, so now this is end of example 2. Let's take a look at the questions. Do I have any experience with Buffalo? I don't have any experience with Buffalo. I actually, honestly, I kind of get the feeling like Buffalo is kind of anti-pattern. It's like, I mean, no offense to the creator, because he's a pretty big Go fan as well. But he came from Rails, and Buffalo was his attempt to recreate Rails inside Go, which is a lot of how you say, magic, maybe not so much magic, but basically it's a lot of batteries included stuff. I don't know how to say it. Okay, I don't have any experience in it, so I can't say it, but I prefer to do things the simple way. Like if I can run SQL, I won't want to abstract it away. If I can choose my own router, I will choose my own router, that sort of thing. Oh, okay. Yes. I think my other message got dropped. Have you able to XO command line tool? Yeah, if I'm not wrong, it generates the it's a templating. It's sort of like a templating language, right? So it generates definitions from your so idiomatic Go. Right. Okay. Yes. So it generates code, but the only difference is like it's still SQL strings, right? You know, like in this case, it's more like more structured. You've got actual column types that you can refer to, whereas this is you generate the strings and you don't touch them, because if you touch them, you might mess a typo up or something. So that's like slightly different, but yeah, I've seen XO before. I didn't really choose it because at that time I was still not very experienced in anything, so I just went with like everything database SQL. So does SQL views temporary views? That's right. It does work with views. So I don't know what a temporary view is. I don't think I've never used a temporary view, but it definitely uses views. It definitely generates definitions for views as well, because I use views quite heavily, and that's a good thing, because views, you can write views for your current tables, and then you generate type safe definitions for those views, and now you can use them everywhere in your code base as well. It's great. Oh shit. Okay. Yes. So example 3. Give me a sec. Computer's a bit slow. Presenter view. Ooh. All right. Okay, so example 3 is about handling nested structs and nulls. So what did I write here? Okay, so previously you saw the database schema here, and now I've written all the domain structs that map to each table. So you've got users, you've got teams, assignment, and submissions. And yeah, so you'll notice that users is kind of sparse. I actually left out created deleted at, but I don't think it's important right now. Like it's an oversight, but it's not really important for this example. Okay, so team struct. You'll notice that although I have a team ID here, I did not have a team ID here because it's a different way of nesting them. Instead, because I said before, a team will have multiple users. So now a team has multiple users, and in this case, it's up to 2 users, right? And then instead of having, so it will just contain a reference to a user instead of the user containing a reference to a team ID. And then assignment is here and here, and this is the nested way. Like, just to give a better overview, this is how everything builds up. So every submission nests assignment, team, and users in this particular way. So a submission has an assignment, a team, and each team has 2 users. That's how it is. That's how nested it is. So handling nested structs in Go, if you're using the database SQL, nested structs require a lot of code to fill in all their fields. Just look at all these fields over here, right? It bloats your query, and code is very error prone because you have to write a lot of opaque strings, and code that you write for handling these nested struct mapping is not reusable. So how SQ handles nested structs is, you've already seen the concept of a mapper function, where it's a function responsible for mapping a column into a particular struct field. So you don't have to write mapper code to handle child structs, because child structs themselves have mapper functions. So what it means is submission only has to handle this, this, and this. To map assignment, it just calls assignments mapper function. To map team, it calls teams mapper function, which in turn calls users mapper function for user 1 and user 2. So you reuse code this way. And now for handling nulls, there are 2 ways of handling nulls. If you try to scan like a null data into a primitive type, you get a error, you get a runtime error. So if you want to handle it without errors, you either have to scan it into a pointer, such as a pointer to a string, or you have to use a null struct such as sql.nullString. So the downside of pointers is that you can't dereference them in HTML templates. So if you're using them, you gotta find some other way, or you have to use option 2, which is this, but it pollutes your domain structure for implementation detail, which is SQL.nowString. Like, imagine if you're returning an API, a JSON response to some JavaScript front end, and then they're gonna see your payload like there's instead of a nice string, you have a object with a valid field and a string field, and they'll be like so confused because this is a Go only thing. And it's unpleasant to constantly deal with SQL.nowString repeatedly instead of just a primitive string itself. So how SQ handles nulls is nulls are converted to 0 values implicitly, but you can still check for the nullness separately in a separate function call. So let's take a look at what that means in an example. All right, so this is what I meant by very bloated and ugly. This is a query. This ugly query basically pulls in every single table that I mentioned over here. It joins all these tables together. And it joins the users table twice because there are 2 users. So I'm doing a self join and then I'm doing extra filter so that these 2 users are different. And then I'm pulling all these columns in. And then after that, I also have to scan it in the right order. So maybe I'll just show the. So I've got submission ID here, here. Again, it has to be in the same order, otherwise I get a runtime error. And what is more important is that in this case, you'll notice that this is a left join. So a team can be null, a user 1 can be null, user 2 can be null. What am I going to do? I'm going to have to use like these things here. I'm going to have to generate a lot of temporary variables because if you look at the definition of a a submission down here, you notice that I'm using all primitive types. So I have to instantiate a lot of intermediate SQL null structs, null ints, null strings to handle the possible null values, scan them in right here, and then I check for error. And after that, I transfer the data over to the actual domain struct itself. So this is really error prone. Like I'm introducing so many local variables in the scope. I could just mistype one of them. Like I've got user 1, user 2. What if I accidentally wrote this instead? Yeah, it's very dangerous. So that's that, and it's also very boilerplate heavy because of the whole null handling thing that requires all these variables here. So now take a look at what SQ is. It's very short. Well, relatively short. It's 42 lines. Okay, so in this case, I'm pulling in a lot of tables, instantiating the submissions, assignments, teams, users table. I'm instantiating 2 of them, right? You notice it's users as U1 and users as U2, and I'm assigning them to 2 different tables here. I'm doing a bunch of joins, order by, but the most important thing is this selecting, which is like super compact. And that's because if you look at the mapper function, it's a mapper function that takes in like 5 tables. So this submission ID is mapped to this submission ID here. And then when I hit assignment, I just call the assignments row mapper function, the mapper function here. Scan into is like a generic version of scan. So for scan into, sometimes you have different database values that implement the driver.scanner or something like that, the interface. So for those types, in this case, answers is actually a JSON field, and this is a JSON column. So I don't actually have a row.json function. I don't have a row.json. So the only way to get around it is to just directly do a scan into, scan this column into this, the address of this variable. So that's what scan into is, right? Team will call the team's row mapper because it's a nested struct. And then if you chase the mapper functions, the team mapper function again calls user 1's mapper function, and it passes the user 1 table in. And then for the user 2, it calls user 2's mapper function, and it passes the second user table in. And then you notice that I'm using this code written here twice. So just like that, mapper functions calling mapper functions, I can just call a mapper function at the top level. I don't have to care what columns they're selecting because they'll take care of what columns they're selecting and what variables they're selecting into. They'll populate this submission struct accordingly. And then for the accumulator function, I just, after each mapping iteration, I just append it to this submission slice and I'm done. Right, yes, and also you'll notice that the whole thing about null values is avoided, but let me tell you how you want to check. Let's say if you actually want to check whether it was null or not. So maybe you want to do something like this, right? Bool. This is actually a flag to check whether the entire team is valid or not. Like maybe if this is all null fields, this will be not valid. How you check is just check whether the team ID is null or not. Because if you think about it, if the team ID is non-existent, everything down here will be null as well. And it's very simple to add on. You just do valid equals to row dot int valid. Int valid is the the corresponding function that checks whether this integer value is a valid column, and then I'll just t.teamID. So just like that, I can check. Basically, this will return, if you look at the definition, int valid returns a bool value indicating if the number field that you pass in is non-null. So that's how you check whether it's actually null or not. But otherwise, if you don't need to really know whether it's null or not, you can just implicitly convert null values into 0 values. So if this was null, it will just get, this will get assigned 0. So that's it. Okay, so question, any specific reason to, okay, so any specific reason I've not tried to make the generated names more Go idiomatic? That's interesting because I also have an example over here. Right, the reason for all caps, right? So the reason for all caps is Juke does it. This is actually a huge inspiration. If you know Juke, it's a Java query builder library, SQL builder. It's exactly the same thing. So basically, see, Java also uses Go's, not quite mixed caps, but it also has it doesn't use underscores. But in this case, Juke decided to go with these all caps for the names, the column names. So it's like, okay, fine, I'll just copy them. Second reason is it's SQL. It's not Go, so it's fine if it doesn't follow Go convention. So these are the two things, right? Go requires exported fields to be capitalized, and SQL is case insensitive, so it uses underscores as word delimiters. So all caps is like a combination of the two. So it's both capitalized and it's delimited by underscores. So you don't have to do any sort of underscore to mixed cap translation. You literally just uppercase everything and lowercase everything if you want to translate between SQL and Go. Yeah, and it's also easier to read because like the table and column names visually stand out from your application code. If it, in the case of, you see here, I've got team ID mentioned here 2 times, but you know this is a column and this is an actual int because of the naming convention. Okay, yeah, so that's example 3. Example 4 is about programmatically building queries. For something called the structured query language, working with SQL in Go is actually quite unstructured because the only way to interact with the database is by sending opaque strings to a database. There's no protocol for sending more structured objects. And in the scenario, what happens if you want to query data based on user input? So I have this code here. So this is simulating user input. So let's just pretend that these variables you see right here are something that you got from the user, something that user input manually at runtime. Okay, so I want to select a bunch of users, and depending on whether the values passed in were zero values or not. So basically, I'm saying if the user passed an empty string, it means he doesn't want to filter anything by string. But if he passes in something, it means he wants to look for a user, a name who contains this string over here. So if you're familiar with Postgres's SQL's wildcard operator, it means this percentage means it can be any character, any amount of times. So basically, I'm just saying I want a word that contains the letters E and S inside. And then I want an email that contains this string inside. And so I have this selecting, and then now I'm going to check, okay, did he pass in a name? And if he did, I will pass this in. I'll append this into a list of predicates, and I'll append the argument inside as well. And then email, did he pass it in? If he did, append this u.email I like into this predicates as well. Created that. So did he provide any values at all? Is it a 0 value? If it's not a 0 value, then I'll say, okay, I want to create that between the start and the end values. And at the end of that, I'll just generate a query with the predicates, and they're all joined together by the AND operator. And because I'm using Postgres, which has this quite inconvenient syntax of placeholders that require you to use numbers, so you can't just use the MySQL's question mark, question mark, question mark. You have to use like $1, $2, $3. I have to run an extra code to convert all these question marks because I can't use dollars here, man. I don't know whether this is actually $1 or $2 because that will depend on what happens up here as well. So I use all dollars down here, and then at the bottom I rebind all of these question marks into the actual dollar symbols. And if I run the query for vanilla, you can see the query right here. Yep, you can see it works as usual. So I like this, like 2 between 3 and 4, and then you've got these arguments at the bottom here. So this is a lot of string building. It's not something you want to put in your business logic. Like it's not something you want to concern yourself with, and that's what SQ lets you do. So you've still got these things: simulate user input. Now you just instantiate a table. You start with this query, select these columns from this table, and then you check the name. Did he pass in a value? If he did, just add where this. Then email. Did he pass it in? If he did, then where email I like this particular string. I like this string. And then after that, created at is if he passed in a non-zero time values, then after that, again, between this time start and time end. And then you just have to run to SQL to get the query and the args, and then you can print them out. So if you just run it this time, you get exactly the same thing. Let's compare it. Vanilla and SQ, and you can see that they're exactly the same arguments, except this one you didn't have to concern yourself with string building because it's all handled by the query builder library. Okay, so wait, one minute. Okay, wait. So now there's another question. Why am I using printf's funcs without parameters? What? Printf? That sorry, which printf are you talking about? There's I mean there's printf and sprintf and printline. Yeah. Could you clarify the question? Well, printf. Oh, did I write that somewhere? Right. And oh, you're right. I'm sorry, man. That's I thought I was gonna put I thought I was gonna interpolate actual values inside. Then I realized no, it's a prepared statement. You're not supposed to interpolate anything. So I forgot to leave that out. Yeah. So that's a pure mistake. It's supposed to be something like this. Yes, that's right. Okay. So there are more available SQL features supported by this library, which I'm not going to go through. You can check out the links in the top. Basically, it supports upserts for both. This is for Postgres, insert on conflict, and MySQL, insert on duplicate key. There's update, delete with joins. So you can join tables in your update and delete queries. There's subqueries, common table expressions, row value expressions, case, union, intersect, except. You can generate type safe definitions for your PL, PGL SQL functions as well, which I also use. Like I wrote a bunch of PL, PGL SQL functions and I generated so that I can call in type safe from my Go code. And you can also interface with the array type from native Go slices, which I think you also saw in example 2. Over here, you can see here I have a list of even numbers, and what I'm actually doing is in a slice of even numbers, and it converts into oh, this is not actually a Go array type, but well, basically there's support for slices. You can pass in slices into this, and it will just convert to the corresponding arguments as you would expect. So in conclusion, why is SQ? Number one is you get compile time guarantees about your queries. Like you get existence checks and data type checks that you use you mention columns that actually exist in your table, and you ran all the right operations on the each column. You eliminate the boilerplate with the concept of selection is mapping. So whenever you select a column, you automatically assign it to a variable. So you don't have to do anything after that. It eliminates boilerplates when it comes to scanning data into nested structs and nulls because of the implicit conversion and the mapper functions. And lastly, it's a query builder, so you can programmatically build queries. And bonus is it's easy to adopt in code bases because it's a glorified string builder. So if you have a code base with a bunch of like raw SQL queries, you could upgrade a couple of them, just a select few, to use SQ if you want some type safety or if you want to eliminate boilerplate. And then you just have to generate the table definitions, and then you're good to go. You can use them. No other queries in your code base has to know about the existence of SQ query builder. So that's the end of my presentation. And let me just look at the examples again. I mean, sorry, the comments. Golang, yeah. Man, I mean, this is like a super throwaway sort of thing. So technically, I should be running a linter, but and it would have caught that. But in this case, yeah, a very, very raw sort of thing. So I didn't run a linter for this. Okay, so that's the end of my example presentation. Maybe there's a, yeah.
All right.
If there are no queries, then yeah. Okay.
Thank you, Woon. That was very cool. Very nice. How long do you take to do this?
The holiday law. During the past holiday, right after the previous semester ended.
Okay.
Holiday, yeah.
Nice. Are you going to be actively maintaining this?
Yeah, man. I feel pretty passionate about the SQL, writing SQL. So
okay.
I feel like there should be a better way to write SQL and Go.
Okay. There's one last question though. Not sure if you want to answer that from Michael.
Have you tried it? Oh, dude. Yo, I love the generics proposal. All right, so you saw the there's so much things I could do if there were generics. Like I mean, there's this comparison operator you saw already, right? I have to use like EQ that accepts fields, EQ in accepts in, and Juke, you don't have that, man. In Juke, all you have to do is EQ, and this EQ handles like everything you throw at it. I mean, it's still type safe, it's still integer floats or whatever. But if I have generics, I can do like EQ that accepts multiple types, like a sort of like a union type, I think they're called. And then when I'm scanning, so for example, this that's a scanning tool. I had a scanning tool, right? Yes. There we go. So let's say I have JSON. First, I have to do this because row.int is a function that yields an integer. But I have to use this more clunky way of scanning into the address because I don't know what data type it should yield. So this one, it should yield an integer. It's scanned into, it doesn't yield anything because it scans directly into address. If the preferred way is probably, I think it would be like scan, maybe like JSON or something, like pass in the type argument. And then after that, a.questions. And then after that, sign.questions. I mean, JSON is not actually a type, but basically whatever type you pass in will be the values yielded by this. And then that's more like syntactic sugar for the library, which is going to be great when it comes out. Yep. Okay. So,
okay.
Okay. So.
Yeah. The last version for Ken. Yeah. Okay. Yeah. Not really for you. Maybe. Yeah. Okay. I think we have answered all the questions. Thank you again, Woon. Thank you very much. I hope to see you around in the Go circuit. Keep up the good work. We really like it. Yeah.
Thank you.
All right. Thank you very much. Okay. We have the next speaker and the last speaker for the day. Thank you for staying through. It's been quite an afternoon. 2 great talks. The last talk will be by Ken. Right. Just give Ken a few seconds.
Am I on yet?
Yes, you're on, Ken. Hi. Nice to meet you. Nice to see you again, man.
Yeah, I didn't mean to hassle Bach there or whatever with my questions. I hope you don't mind. It's just I'm also the author of XO, so it might be. I don't know. I'm very, very, very familiar with Juke, by the way. But
okay.
It's an interesting thing to copy for Go. Anyways, cool. So my name is Ken Shaw. I am the CTO of Brankas. I'm also the founder of Go Jakarta, which is the largest Go meetup group in the world. We have, I think, just under 9,000 members, which is almost 25% larger than any other Go group in the world. Today my talk is on plugin patterns with Go. I'm just going to go walk through some common popular packages that were written or that have been written. But anyways, really cool. Really quick thanks to Google Developer Space. I really appreciate you guys hosting the space again. They actually hosted our meetup earlier this month, and so I'm happy that we're doing yet another thing. If you haven't joined Go Jakarta and you're in Indonesia, please join our group. We've got meetup groups, we've got Telegram groups, we've got Facebook groups, and other stuff. So all of these slides that I have are available online, and all of the code that I write is compilable. So everything you see here in the slides, you can follow along at home if you'd like to. It's just go get -u gophers.id slides, assuming that website works. I may have taken it down, but I'm pretty sure it's still up. Otherwise, it's on github/go-jakarta. So just real quick prayer for speakers. We're looking for presenters, obviously, for Go Jakarta, but also for this GoSEA group. So please contact either me or Winda, who was at the very beginning of the talks today, was on the screen. That's our contact info if you'd like to drop us a line. We're looking at doing a joint meetup with Tokopedia in either late October or early November, so please stay tuned for a Go Jakarta thing. And my company, Brankas, we're a relatively, let's say, medium-sized technology company based out of Indonesia, but we have engineers all over Southeast Asia in Philippines, Vietnam, Thailand, Singapore, and other locations, as well as, Europe and the US. Oops, oh, that's a duplicate. Sorry about that. All right, so let's get into the presentation, plugin patterns with Go. So there are a few common ways that plugins are used in Go. The most typical one that you see, and that I'll cover here a couple of times, is basically the package-specific interfaces. The other way would be to do a shared struct containing func members that have the various options that you can use, which I'll show a very clear use of that in a application that I wrote. Using the standard library reflect or func type signatures, so you analyze it using introspection and reflect, and then basically use metadata stored in struct tags. This is a more common way. You don't necessarily find it in, let's say, quote unquote plugins, but it's a way of plugging in other code into it. And kind of the most interesting one that I walk through here today is, or at least do a little bit of analysis on, is a socket or a pipe-based parent process that delegates to a child via a TCP socket or a Unix pipe. This is kind of a way that a lot of statically compiled languages are now approaching plugins or like plugin frameworks. So one example would be gRPC that uses the various code generators, the protobuf code generators on the command line that pipes directly in via Unix pipe the actual generator. That's not written in Go, so I'm not covering that here tonight, but that's kind of the way. The other way is to basically do dynamically loaded or to dynamically load statically compiled code that exists in a .so or a DLL file. But the problem with doing that in Go is it's not really an approach that I've been able to find in the wild in many packages. It really only works on Linux using the C build plugin or build archive or whatever the name is. And you can do it, of course, with DLLs on Windows. And I believe there's a way to load dylibs on Darwin as well. But for the most part, it's not consistent across platforms. So it's not really an approach I'm going to cover tonight and outline on how it's actually done. So there are many popular Go apps with plugins. You know, I'm kind of going to go through the primary use cases or the very common forms. That's the database SQL one, the Logrus or LogRUS. I'm not really sure how you pronounce that. USQL, which is an application that I wrote for the command line. And I'm also going to go a little bit over Kubernetes and how its custom resource definitions work and how you can you know, implement them yourself. So to kind of go through from a high level here on how the standard libraries SQL and its drivers packages work is that you and this is kind of the prototypical Go example of how to really write plugin modules, meaning where you can take your code and plug it into the system. So for example, you've got a standard SQL package, but you've got, you know, many interchangeable drivers that can act as the backend for that SQL, so that you can use the same SQL functions, but you know, use a MySQL backend or a Postgres backend or a SQLite backend or whatever you might want there. But the way that that typically works is that the drivers will register themselves using a high-level init func that is included inside that package. So when you include that driver, typically via an unnamed import, it will register itself with the you know, the actual Go system or the Go package itself, and be available for you to use during runtime, essentially. What's really nice is that since everything is statically defined this way, driver signatures are validated, and you know, you can kind of know that things are going to work at build time, so to speak. Whether or not the actual implementing code is, you know, bug-free or works the way it's supposed to is a completely different topic, of course. So just this is a very high-level overview of what the implementation in the actual database SQL driver might look like, and what you would, how you would go about implementing it. So let's say, for example, I had my own package, my driver, and I wanted to register it. What I would do is I would have, I would declare at a high level the func init. This is a standard init func. If you're not familiar with these are called before the main func is entered in the in a built application. What this does is it basically registers with SQL a type called driver, which I am defining here, that actually implements all of the types that are defined in the SQL driver package. So for example, we are opening, so this is this register call, I believe, is SQL.register takes a SQL a driver.driver implementation, and I believe that interface has just one call defined in it, which is open, or one one member func, I should say, that's open, where you pass the name of the database, and basically you return a driver.con. Again, that type is defined inside the SQL driver package. It's not defined anywhere in this, and your type that you would define is basically, you know, needs to satisfy the external intermediate interfaces that are defined in that SQL driver package. So for example, what I've done here is I'm now on this, I'm returning a new con. That's this func here. But notice that this con returns a driver.con and an error. And all I'm doing is returning my instance of my con using the past name. And that is this type here. I, of course, am abbreviating the actual implementations for purposes of brevity. But these are the only three funcs that you actually need on the actual connection implementation: prepare, close, and begin. Now, the point of this analysis here is not really to discuss how the SQL driver works, but to give you the kind of the pattern of how this is actually implemented if you wanted to go and implement it yourself. So this is useful for anytime that you want to enable third-party packages to provide extensible code or an extensible plugin that works with your system, but that may not necessarily exist within your package or your repository, or however you see that. Now, the way that that code then is used is you would import this on an unnamed import. This is the example.com my driver. That was the package that we had just previously defined. And then on that code, you would do SQL.open, passing the name of the driver that you registered it as. Actually, I made a mistake here. This should be my driver since I registered it here as on the SQL.register call as my driver. So that is a typo, so I apologize. But basically what that is passing it using the parameters that you are giving it. It's the name of the driver, etc. And that open call is basically this open here, and then passed here using the new con connection, and the SQL database, sorry, the SQL driver package would build an internal driver for that and essentially pass the queries directly onto it, essentially. So this is just to give you really an idea of how it's done. And what I want to point out here is that this SQL.open does not return an instance of your connection directly to the user. Instead, it returns a SQL.database or a SQL.con, which is a pointer. I believe it's a pointer to a con or a pointer to a database connection that you then use that type, and it essentially works and passes on the queries or the calls to it. So this would be very useful. For example, of course, you know, the prototypical example of using or implementing something like a SQL driver data package, or for example, if you wanted to implement a number of different write backends or a number of different hosts. So another example that I could think of is for if you wanted to abstract something like, let's say, from the talk earlier about a workflow. So, you know, hypothetically, somebody could write a high-level workflow package and then write different plugins for the different for the different workflow systems that are out there, such as the temporal one that was discussed, or let's say maybe Kafka or some other kind of system that could work in a similar fashion. All right. The next example we're going to go through here is Logrus. Again, I'm not sure if it's Logrus or Logrus. Not really sure how to pronounce that name. But if you're not familiar with it, it's a very widely used logging package, probably the most used logging package in the Go world, short of the standard libraries log package. What it has is it has a so Logrus has a much simpler hook mechanism that allows you to define different backends for where log files are sent to. So, for example, they have a backend for syslog. They have a backend for Datadog. They have a backend for Stackdriver. They have a backend for essentially every logging service or protocol or application that does logging or records logs for you. But it has a very similar pattern to the database SQL package, but it's fundamentally quite different because whereas with SQL drivers, they typically register themselves when you do an unnamed import or a name of that driver package. Logrus is different in that you configure it and then you at runtime dynamically add it to your logging instance, right? Your Logrus logger. So it's significantly simpler and much easier, and it's kind of a very good example of how you can enable a much simpler kind of a thing if you don't need it to do a much a super complex or dynamic plugin module like what the SQL database, the database SQL package provides. So this is just a very quick implementation. So I'm creating my own hook implementation. So for example, I'm creating my own type my hook. And what I am doing is I am then, satisfying it because I do need to satisfy the one logrus.hook interface, which is basically defined as these two member funcs, levels and fire. And then we basically just return that. But notice here that in the pattern is that I'm actually returning the direct instance of my hook as opposed to an intermediate third-party type that, so for example, I'm not returning a logrus hook type. I could, but you don't need to, and this would be the more idiomatic definition here. But then basically what this is the way you would use it is, again, this is kind of different. Notice this is being done in func main, is I'm creating a new logger, and then I'm doing logger.hooks.add my new hook, and I'm passing whatever options. And again, this is just an analysis of kind of the patterns, the mechanisms of how it's done. But it's worth kind of knowing these different patterns to understand how they work or to know how you might implement it, yourself in the future. This is probably the most common kind of hook, plugin pattern that you'll see in the wild. I've seen very, very few packages that require, anything that's much more heavy or as, complex as the SQL database package. So you'll see this kind of style of much more common, and to a certain extent, this is a more idiomatic version of it. Not that the SQL database package is not idiomatic, it's just that my guess is that if the original package implementers for that package would go back, they probably would change some of the APIs to look a little bit more like this, maybe not doing the unnamed import stuff, just because the database SQL package is probably one of the oldest packages in the Go standard library. Definitely predates the 1.0 days. So the next pattern we're going to analyze is from an application that I wrote, which is a USQL. If you're not familiar with it, it is a command line interface meant to pay homage or tribute to PSQL. But basically what it does is it takes a PSQL-like command line interface and then uses all of the community contributed database drivers for Go. Now, as opposed to logrus or with the database SQL package, I do have a plugin system in USQL, but it's for a much different intent. USQL is not really intended for you to contribute outside code. If you're going to contribute a driver to USQL, it's going to exist and sit inside the USQL repository. So the necessity to have a generic plugin system is not really there. So instead, what I do with USQL is that I just define a single high-level driver type that every registered driver in USQL that essentially provides the plugin for that database. It's the exact same type, and essentially using that same type is all that you have to register. So there's no interfaces, there are no intermediate types, there is no reflection, there is no introspection. It's just simply based on whether or not that driver implements that functionality. And the reason for that and why we do it this way is that because of the nature of USQL, there is a lot of this same shared functionality that can basically be stubbed, and it kind of works on a more USQL is designed more towards to be you know, a platonic ideal of what a command line interface is supposed to be. And so in order to accommodate the, I think, 15 different databases that it supports, you know, it needs to be more of a generic kind of a tool than, for example, you know, these other things are. So a lot of that functionality needs to be filled in, and that's why we stub everything. And instead of, for example, forcing the driver, every driver to have an independent implementation, there's a primary implementation that is shared inside the USQL code base. And instead, what we do is we just basically check that struct, that shared driver struct, for the presence of an option or a function that implements a specific part of the code. And basically then that's how we determine whether or not to pass that on to the underlying driver. So this is an actual copy from the USQL code base, the type driver struct. This is in our SQL drivers. This is the SQL drivers, sorry, USQL drivers.driver type. Now, there are a lot more fields in this and a lot more various functions that delegate responsibility to that. But basically what this is I've got, what I want to showcase is that I'm able to mix and match essentially options as well as functions that provide the same kind of behavior for that type. Now, the reason I do it this way and not a different way is that it's very difficult. No, sorry, it's not very difficult, but it would be very cumbersome in Go to write a, you know, to kind of essentially, you know, mix and match types. And there's, for USQL, which is a very, you know, standalone, you know, single source package, or not package, command, there's no real necessity to kind of branch off or provide, you know, the dynamism of an interface or other aspects, if that makes sense. So what we have here is one function and one Boolean option. There are a number of other configurations. And so this plugin style, you can actually think of it as something more like an options plugin, or more like a C style plugin. So this style of plugin actually comes from my C coding days. This is more along how you would write a plugin style system in C, which is you would define a single you know, type that, or you know, that basically has all of the fields that you are going to use, and essentially use them when they're there, or use it for configurations or options. What's nice about this, again, I want to emphasize that I don't now have to do type assertions on checking whether or not a driver supports certain functionality, or whether or not you know, they're or having to rely on reflect to get tags from a struct or whatever it might be. So it makes for a much cleaner and simpler code base in USQL itself. Now, the way that driver use it, and this I just want to show you what it would look like, is that drivers can then basically selectively choose what functionality they want to implement or not implement, or what options or what their behavior is for that option. Now, because there are, I think, maybe 30 or 40 different fields in this driver struct, you know, each database driver, you know, only defines the functionality that they want. And this is a much nicer style than, you know, having you know, as opposed to being an interface, because if it was an interface-based plugin, each driver would have to implement every single one of those 30 base points. Or, as I said before, I'd have to do a type assertion on that type, on the registered type, to basically check whether or not it supports certain functionality. Now, this just basically shows you how this would work, is that, let's say this is an error function. You know, what we're doing is we are basically encompassing the mydriver.error. So let's go back to that original SQL database plugin system and talk about that. And let's say I define an error type inside that package. This is how I would do this in a way to just essentially extract the information that would be used in USQL. And in this case, I'm returning 2 strings, which would be the error code and error message. Now, how that actually ends up getting used is essentially something like this. There is a global drivers map that maps a string of the driver name to just essentially drivers.driver, as opposed to some interface or something like that, which is, or to something else, which is essentially how a lot of the other plugin systems do it. And the way that that's done is like this. I would essentially check the presence. So if the defined driver $allow $, then I would do the special code for $ quoted strings, for example, here, or I would then have an else or some other different implementation for those databases that did not have that, that did not allow $ quoted strings. Similarly, the way that the error func would be done is something like this. Is, let's say I got an error returned back from that driver. I pass that driver around, and basically then checking that error, and then getting the message back from the actual implementation itself. Now, I realize that this is essentially almost a replica of the previous one, but there are databases in USQL that do not implement the error func at all, and so I'm checking for its presence just simply on nil. Now, I realize that this is kind of taking a step back from object-oriented programming. This is not object-oriented programming. This is not type-based programming. This is kind of a prototypic, like an old world version of how object-oriented programming was done in C and in other statically typed languages prior to the invention of objects, which is why I feel that this pattern really fits in well to Go, because Go really is inspired mostly from the C kind of world and not by the Java or C++ or other object-oriented languages world. The other thing that I've kind of done as well from a plugin standpoint, and this is something that I've seen in a few different apps that are written in Go, is that you're basically able to dynamically include or not include those individual drivers based on build tags. And if you're not familiar with Go, just know that you can do that by including or not including that by simply adding this on that code. Now, when you have it all self-contained with that init func in the register, when that code does not get included into your code, it just basically means that that driver will not be available or defined in that global level map somewhere. Okay, now the last kind of example that I want to go through here is basically Kubernetes. I'm sure many of you are probably familiar with Kubernetes, or at least have heard about it. But in Kubernetes, if you're not aware of the architecture of how it works, there's basically an API server that manages, or multiple API servers that are basically the master nodes that manage other nodes and basically delegates their behavior to that. Additionally, if you want to actually create a custom resource in Kubernetes, it has an extremely flexible API that allows you to define any kind of API, any kind of resource, and the Kubernetes API server itself will actually manage that resource for you, so you don't have to worry about storing it or defining it, and instead you just provide the implementation. Now, on a custom resource definition, you can have essentially something that's a controller that is essentially a gRPC-based server itself that basically is managed by the Kubernetes API server, and essentially when an event comes in, that event gets replicated to that client process via gRPC. So this is kind of the other example. This is probably the most complex and most advanced style. But what's interesting about this, the way that it's done, is that even though most controllers in Kubernetes are written in Go, and the API server itself and all of Kubernetes is written in Go, you can actually have non-Go based plugins essentially working, because what you're really doing is you're having two HTTP servers essentially communicate to each other, and not really doing anything else, right? And what's really nice about Kubernetes, and of course, if you wanted to go about implementing it, it would be way too complex and take me way too long of a time to actually go through today. So I'm not going to go through an actual implementation, but I encourage you, if you're really interested in Go or how to do super advanced plugin systems, that this is the way to do it. But everything that Kubernetes is doing, even though it's doing it in a hyper distributed fashion, you could just do it on a single host with a single child process. And basically you would have a parent process that launches a sub process, a child process, and then they just essentially communicate through standard in and standard out, the actual encoded data. So for example, a HTTP request, there's absolutely no reason why you can't just send an HTTP request directly over it. And you can, of course, use gRPC or a JSON encoding or something else, to do a parent to a child process. And this is kind of the other style of plugins, and I've actually seen this quite a few times. There's a number of other apps that are very complicated, like Kubernetes, that also do this kind of pattern. Not necessarily written in Go, but in Java or in other languages. Now, one of the really kind of interesting things about this, if you wanted to do this, is that you can actually build to a static API specification. It's backward. Typically, it can be backwards and forwards compatibles, and Kubernetes itself is backward and forward compatible, whereas the other approaches that I discussed are not backward and forward compatible. And what's really interesting is that when you have it like a system like Kubernetes, is that you can actually change the server while the child is still running, or have the child changed while the server is still running, and still actually allow them to have some kind of interoperation between the two. Now, in distributed systems, the apparent benefit of that is somewhat obvious, but it's nice to know that these things can be done, and can be done fairly easily using the Go programming language. Anyways, I encourage you to look at it, and that's kind of it for my presentation. So thank you. I really appreciate it. I wanted to make this presentation relatively quick, since it's a Saturday, and I'm sure everybody wants to get on to their own personal things to do today. But thank you. If you have any questions, please let me know. Again, my company, Brankas, is hiring. Please send an email if you're all interested. We do everything in Go, basically on the back end, and do a bunch of Kubernetes stuff as well. So thanks.
All right, thank you, Ken, very much. Let's take a look if there's any questions. There's one on the street. Yep.
So how is a Kubernetes CRD different from a regular service call? So basically, I assume you mean like a regular service call to the Kubernetes API itself. So the Kubernetes API server will actually relay that message via an event to the controller that's running, and that controller is a full-formed process that's running on as a pod somewhere on your Kubernetes cluster, or basically this same plugin mechanism is used for operators and the other kind of components that are in Kubernetes as well. But a controller is very clear that it basically gets allocated as a pod. It runs as a pod. It communicates in a distributed fashion. You can have replica sets associated with that CRD and that controller for that CRD. And so that's basically how that goes. So that's how it's different. What the CRD controller does is it's just essentially an event listener. So there is a standardized gRPC API call that you can implement. Now, Kubernetes provides a standard gRPC client basis and a whole high-level package that allows you to rapidly write a controller implementation or operator implementation or these other things, natively in Go without having to worry about setting up your environment or getting that. But hypothetically, you could actually write all of that directly yourself and just receive those gRPC events. I believe I've looked into it, quite a bit. By no means am I an expert, but basically it's just a standard gRPC stream. So if you're familiar with gRPC, then you'll know what streams are, and that's essentially how Kubernetes delegates, events or translates an API call to the API server itself to its controllers or operators or other plugins. Yeah. I hope that answers your question.
Thanks for that, Ken.
Yeah.
Then last questions. Let's take a look. Right. There isn't any more questions. All right. Thank you, Ken. And
Yeah.
I think the end of the whole session has been a very informative 2 hours. Thank you to all who have spent time this Saturday afternoon on Golang topics. So yeah, I'll just close it off for the whole event. Thank you very much again for attending. We'll see you around very soon. And have a great weekend again. Thank you guys. And bye-bye.